So first, explain to our viewers what is quantum computing.
But okay, one way that I like to think of it is leave aside all the notions we have of normal computing. It's leave aside bits and digits and numerical computing and logic and all of that, because none of that actually is applied in quantum computing. Quantum computing is really based on the principles of quantum mechanics, superposition, entanglement, and many other principles that are there. And at the core of it, you can think in this way that in digital computers, you have bits which can represent 0 and 1. And with that, you can represent numbers, you can represent words, you can do Boolean operations to do complex calculations, and then you can write programs to do all of that, right? Whereas in quantum computing, there's something called a qubit. Now, a qubit is a quantum bit. Think of it like an electron, right? So for people who know what an electron is, it's a small particle of matter, and it can exist in theory. As per quantum mechanics, you cannot know exactly what is its state, what is its position, what is its velocity. Heisenberg's uncertainty principle, people might have known. So imagine you had a bit which could be in multiple states at the same time, as long as you're not trying to measure it or check its value. And so in a way, it is representing multiple possibilities, not just one out of two. And so if you take 100 qubits and take them through certain transformation, physical transformation, then you sort of can compute multiple possibilities. And then finally, when you measure it, it will collapse onto one out of those multiple possibilities. So what you do is you keep doing that again and again and keep measuring to understand the probability of what the final answer would be. So you actually treat it like a quantum mechanical system, right? So people who know about the double slit experiment, where you throw photons through it, when you throw one photon, it shows up in one place, but then you keep throwing multiple photons through it, and you start seeing a wave pattern. So that's like the multiple sampling you do through the quantum system, and that reveals to you what the actual answer is. So it works in this kind of quantum mechanical principle. But there's the trick now is, how do you map real world problems, like if you have an optimization problem, onto this concept? Because this is a very different concept.